Factors affecting speed of sound. Number 1, medium. Sound travel slowest in gases, faster in liquid, and fastest in solid. We have discussed also speed of sound in air is 331 meter per second. In liquid, that is water, 1450 meter per second, and in iron 5130 meter per second. Sound travel about 15 times faster in iron than in air. Number 2, temperature. The speed of sound increases on increasing temperature of medium, that is on increasing 1 degree Celsius temperature. The speed of sound increases by 0.61 meter per second for each degree Celsius. Therefore, at room temperature, the speed of sound is more in comparison to the speed of sound at 0 degree centigrade. Third, humidity. Humidity is amount of water inside the atmosphere. That is, more humidity, we are having more amount of water vapors inside air. Now the speed of sound increases on increasing the humidity of medium. Fourth point, there is no effect of pressure on the speed of sound. Sonic booms or shock waves. When an aeroplane is moving, that is jet fighter is moving above a building having glass windows, then sometimes it is found that due to very high speed of jet aeroplanes, the glass of the windows break. Therefore, jet aeroplanes are flying at a greater height, that is more than 2000 feet, so that there is no damage in the tall buildings. Let us come to the topic. Sonic boom is an explosive noise, very large noise, caused by the shock waves. Shock waves are produced by supersonic aircraft or any other object like missile, which is traveling faster than the speed of sound. Due to the very high speed, a supersonic jet or a missile produce extremely loud sound waves are called shock waves in air, and these shock waves increase their size and comes to the glass windows, and glass windows break. Therefore, sonic booms are the waves having very large amount of energy, and they transmit energy to the other molecules. Example, bullet, jet aircraft and supersonic aircraft, missiles are the examples of it. Properties of sound waves. Sound wave can be reflected. Property number 1, reflection. Here two pipes are shown. In front of one pipe there is a clock producing sound, and other pipe is getting here reflected sound. Ear is placed there. In front of P pipe there is a stop clock producing sound. S is the separation between them, and Q is another pipe receiving the reflected sound. Then here reflection of sound is just like the reflection of light, and angle of incidence is equal to angle of reflection. This is the first property of sound wave, reflection of sound wave. Second diagram, refraction of acoustic wave. Acoustic waves are sound waves, that is medium 1, medium 2, wavelength 1, wavelength 2. When the sound wave is traveling from air to glass, air to water, then there is change in the speed. Sound wave is shown here from traveling from one medium to another medium, and it is not moving in the straight line, it is bending from the direction. This shows here velocity is changing, that is refraction. Second property of sound wave, refraction. And third is diffraction. Diffraction means bending of sound waves when an obstacle is coming in their path or when they are getting the chance for bending. If example is here, if we are having a closed room, windows are closed, then doors are closed, outside there is a sound produced by explosion, we can listen the sound inside the room. Reason is that sound wave can bend at the edges, at the corners of the doors, window, so that they are audible inside the room. Wave interference, that is the fourth property of waves. Interference means redistribution of energy. When the two sound waves of equal frequency are traveling in same direction. In this way, they are supporting and making constructive interference. Supporting means energy becomes more than the energy of the two waves. There is transfer of energy. There is transfer of loudness. Sound becomes more loud. In the destructive interference, the two sound waves are destructing each other. They are destroying each other. Intensity becomes low. Sound becomes loud, that is very weak at the places. In the third figure, two speakers are kept there, just like in the cinema halls. Two speakers are kept one side of the cinema hall portion, and another side. Both are having same sound frequency, but giving the waves in the same direction. Then due to interference, at some places sound becomes more and sound becomes less. To avoid this, the curtains on the walls are covered in the big cinema halls, and the roof is also made to absorb the sound, so that there is no chance of interference in the reflection of the sound waves. Here at the last figure, two speakers are in front of each other and producing sound. Then due to destructive interference, sound of one speaker is destroyed by another speaker sound. Reflection of sound, that is the first property, reflection we have discussed. The sound wave obey the laws of reflection, and second property, refraction also. Reflection and reverberation. Reverberation or multiple reflection of sound. The laws of reflection of light are obeyed during the reflection of sound. Applications now. Number one, stethoscope. It is a medical instrument used by doctors for listening to the sound produced within human body like heart and lungs. The reflected sound is coming through a pipe, reflecting continuously inside it, and it is observed in the ear of the doctor. Sound waves are shown in figure, and they are the disturbances as shown in figure, not in a regular shape, because molecules are having less displacement, more displacement. Maximum displacement is known as amplitude. Another figure of sound wave is here. Now let us come to second application. Cinema halls and conference halls. The ceiling of conference halls and cinema halls are made curved so that sound after reflection from the ceiling reaches all the parts of the hall. The soundboard is a curved board which is placed behind the speaker in large halls or auditorium so that speech can be easily heard even by the person sitting at a considerable distance. In the figure 1, the person speaking is placed at the center of the curved surface and sound after reflection becomes parallel. That is, sound wave becomes parallel. And in the second figure, here is a curved roof of the conference hall. The speaker is producing sound and it is reflecting and then arriving to the object. Horns or megaphone. Megaphones or loudhailer horns, musical instruments such as trump are also designed to send sound in a particular direction without spreading in all directions, so that more amount of energy transfer in a particular direction. Trump is the example of it, and another is megaphone shown in the particular shape to regulate the energy in a particular direction. Thank you.